Okay, so what you see here is assignment 1.1. And what you have to do is you have to determine if each of these is a function or not a function. And then on page 2, you have two columns. One's a function, one says not a function, and you have to put these in the appropriate column. So I'm going to show you how to determine if these are functions or not functions. So let's start with A. Start with A, right? Oops, let me put my pen. Okay, we're going to start with A. And the thing to remember is that a function relates one input to one output. Okay? So one input to one output. X's are your inputs. The Y's, those are your outputs. Okay, so the X is your input, the Y is your output. And I want to make sure one input goes to only one output. Okay? Let's look at this. We have a 1 right here. And it goes to a 2. Alright? We have a 2. It goes to a 2. We have a 3. It goes to a 2. And we have a 4. And it goes to a 2. Question is, does every input, does every X go to only one Y? And yes, it does. This 1 went to only one Y. This 2 went to only one Y. This 3 went to only one Y. This 4 went to only one Y. So this is a function. I just put F, that means function. Let's go ahead and look at B. Same thing. X's are your inputs, Y's are your outputs. With a function, every input goes to only one output. Let's see if that's true. This 5 goes to a 4.5. This 6 goes to a -6. This 7 goes to an 8. This 8 goes to a 5. So in each case, the X went to only one Y. That is a function. Okay? Now I'm going to go down to C. Same thing. We're determining if this is a function. Does each input, which is the X, go to only one output? Now watch this, because I'm going to tell you right now, this one is not a function. But let me show you how we can determine that. This 5 goes to a 4. But look here. We also have a 5 right there. And it's going to a 4. And I'm wrong. This is actually a function. So disregard what I said. Okay? We have a 5 going to a 4. We have one X, which is a 5, going to one Y, which is a 4. Okay, so that is one X going to one Y. So that is a function. The 6 goes to a 7. The 7 goes to the 8. That is a function. I'm sorry, I was wrong on that one. That is a function because that is one X right there. 5 and 5. That's one X going to one Y, a 4. They just repeated it. I don't know why they repeat it like that. But this next one, D, is not a function. And let me show you why this is not a function. I have an input and output. To be a function, each X has to go to only one Y. Here's an X, a 2, and it goes to a 1. But look here. I also have the 2 going to a 2. Okay? So I have one X, a 2, going to 2 different Y's. Immediately, I know it's not a function because in a function, each X goes to only one Y. Here I have one X, 2, going to 2 different Y's, 1 and 2. Also, look here. I have a 2 going to a 3. I have a 2 going to a 4. So in this case, you have one X, the 2, that's just one number, it's a 2. Same number. going to 4 different numbers. Okay, so that's not a function. I'm going to put NF, not a function. And I'm going to tell you right now, you can tell if it's not a function if you have a table like this, if your x's repeat. Okay, if your x's repeat, it's not a function if they go to different numbers down here. Right here they repeat it, but it went to the same number, so it was still a function on this one right here. Okay, that's why this one was a function. The x's repeat it, but they went to the same number. Here your x's repeat and they go to different numbers, so you know it's not a function. Let's go ahead and look at E. E is a mapping, so it's different than what we have been doing, but it's the same thing. This right here you can think of as your x's. This one right here you can think of as your y's. Okay, so on the left is your inputs, on the right are your outputs, and I need to make sure that each of these goes to only one of these. Okay, because that's what I said a function is. Each input goes to one output. Well, this one right here goes to a 1. This 2 goes to a 2. This 3 goes to a 3. This 4 goes to a 4. Each x went to one y. That is a function. Okay? Let's go down here to F. Same thing. These you can think of as your x's. That's the input. These you can think of as your y's. Those are your outputs. And each x has to go to one y. Let's see if that's the case. The m goes to whatever this is, but it only goes to one of them, so we're good. The t, right there, the t goes to this, but it only goes to one of them, so that's good. The s goes to this, but it only goes to one of them, and I said each x has to go to one y, so we're still good. And f, each x has to go to one y. Well, this f goes to this. It only goes to one of them, so we're good. That's a function. Okay. So let's go ahead and look at H. Again, x, y. Each x has to go to one y. Well, look at my 1. My 1 goes to a 2, but my 1 also goes to a 4. And I said for it to be a function, each x has to go to one y. Well, this x went to 2 y's. Automatically, I know it is not a function. So I'm going to put NF. NF means not function. Look at the 5. The 5 went to a 6, and it went to an 8. Well, I said to be a function, every x has to go to one y. Well, this x went to 2 y's. Therefore, it's not a function. Okay? Let's go and look at G. On G, same thing. You take these as your x's, these as your y's. And I know that each x has to go to one y. Let's see if that's the case. The 4 goes to a 10. The 4 went to only one y. We're good. The 5 went to a -2. The 5 went to only one number. We're good. The 9. The 9 went to no number. And I haven't said this yet, but that's okay. Okay, that is okay. If a number does not go to a y, it can still be a function. So the fact that the 9 goes to nothing, we are still good. That it could still be a function. But we have to look at 8. 8 goes to a 10 and a 5. That 8 went to 2 different numbers. I said to be a function, each of these x's can only go to one y. Well, this 8 went to 2 numbers. Therefore, it is not a function. And finally, our last one. Here, remember the first number? Can I zoom in on this? Yeah, I can. Remember, our first number is the x. Our second number is the y. Okay? First number is the x. Second number is the y. Well, and that's true for all of these. This is an x. This is a y. This is an x. This is a y. This is an x. This is a y. Oh no, 2 fingers. This is an x. This is a y. Okay? And I need to make sure each of these x's goes to only one y. Well, look here. This first one. That is the x. A 2 goes to a 3. But look here, I have a 2 on my next one going to a 5. I also have a 2 over here going to an 8. I have a 2 going to a 4. I have a 2 going to a 3. I said to be a function, each x can only go to one y. Well, I have this one x going to many numbers. I have it going to a 3. I have it going to a 5. I have it going to an 8. I have it going to a 4. I have it going to a 3. So I have that 1, 2 going to 5 different numbers. But to be a function, that 2 can only go to one number. Therefore, this is not a function. Okay? We got some more over here, but it's the same thought process. Okay? So right here on I, we have the same thing. Let's look at our x's and make sure they go to one y. I have a 4 going to a 3. Do you see any more 4s over here? No. I have a 2 going to a 5. Do I see any other 2s in the x position? No. I have a 1 going to an 8. Do I see any other 1s? And all these numbers, do I see any other 1s in the x position? No. 10, I have a 10 going to a 4. Do I see any other 10s? No, so I'm good. I have a 0 going to a 3. Do I see any other 0s? No. So each of these numbers, the 4, the 2, the 1, the 10, and the 0, are going to one number. That is a function. Okay? I, same thing. I'm looking at the -2 and the 3. Those are my x's. I need to make sure they go to one y. Well, the -2 goes to a 3. The 3 goes to a 5. Each of the x's went to one y. The -2 went to a 3. The 3 went to a 5. That is a function. Okay. On the graphs are probably about the easiest to determine if they're a function or not. What we use is called the vertical line test. Vertical line test. With the vertical line test, what you do is you start drawing vertical lines. Let me zoom in. So vertical lines go up and down. Just start drawing vertical lines. When they hit the graph, if they hit the graph at 2 points, you see how it's hitting the graph here, 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 here. If it hits the graph at 2 or more points, it is not a function. Okay, well, this one hit it, 4 times. Definitely not a function. As soon as that happens anywhere on the graph, it is not a function. That's called the vertical line test. Let's look at this one. So I draw vertical lines until I get to my graph. Right there. And if it hits more than 1 point anywhere on the graph, it is not a function. Well, this hits all kinds of points. It hits an infinite number of points. It's not a function. And see, if we go to R, again, I start drawing vertical lines. Okay, hit my graph, but it hit it at only 1 point. So we're still good. But I keep on going throughout the whole graph. See, it hits 1 point, hits 1 point, hits 1 point, hits 1 point. So long as it only hits the graph once, it is a function. Okay, so remember that's the vertical line test. If it hits it more than once, anywhere on the graph, it's not a function. If your vertical lines hit the graph at only 1 point, you're good. That's a function. And finally, I think it's the final one. We have Q right down here. Y equals 2x plus R. Okay, you'll probably remember from Math 1, y equals mx plus b. This is a linear function. So if I was to graph this, it would look something like, I don't know, this. Okay, if you were to graph this, it's going to be a linear function. Well, it's a function because it's a straight line. We just saw that straight lines are functions like this. Okay.